Hi, and welcome to our discussion of right triangle trigonometry. This should be a review of stuff that you have learned previously. We're going to start by defining the trigonometric ratios. So here's our right triangle and our angle theta, and we're first going to label the different sides. So the leg opposite the angle is labeled opposite. And we know that the hypotenuse is the longest side and it's across from the right angle. And then the final leg that is between the angles, the angle and the right angle would be the adjacent leg. So you've learned an acronym to remember the trigonometric ratios, SO, CA, TOA, where sine of theta refers to the ratio between the opposite and the hypotenuse, so O over H. And cosine theta refers to the adjacent over hypotenuse. And finally, tangent of theta refers to the opposite over adjacent ratio. So these ratios are going to be really important when we start solving different right triangles. So the first thing we're going to do is find the exact values of the following trigonometric ratios. So I've labeled theta here. Notice that I only have two of my side lengths. So if I want to solve for the third side length, I'm going to use the Pythagorean theorem. So the Pythagorean theorem says that a squared plus b squared is equal to c squared, where a and b are the legs of my triangle. And some of you guys might already know this Pythagorean triple. It's one that comes up a lot, but let's go ahead and solve for it. So we have 3 squared plus the other leg squared, which you do not know, and then the hypotenuse is 5 squared. So you have 9 plus b squared equals 25. B squared equals 16, so we know that b is 4. And many of you guys might have already known that as the 3, 4, 5 Pythagorean triple. So let's go ahead and find the ratios for sine, again, opposite over hypotenuse. So that will be 4 for the opposite, and the hypotenuse would be 5, so 4/5. To look at the ratio of cosine, we're going to do the adjacent. So 3 over hypotenuse of 5. And finally, we have tangent, which is opposite over hypotenuse again, 4/5. So go ahead and try the triangle to be right. And again, you're going to have to solve for the missing side length. You can pause the video now so that you can have some time to solve and then replay. Remember, in this one, you should not leave the denominator with a radical, so we're going to rationalize that denominator before we give our answer. And finally, we had tangent, which is so these trigonometric ratios are going to come really in handy, especially when we start to solve right triangles. So to solve a right triangle means to find the measures of all of the missing sides and the angles. And if you notice in this diagram, usually we refer to the acute angles as alpha and beta, where beta is across from the leg B and alpha is across from leg A. So that's just the standard convention that we use and something we sure you'll see often. When we're solving for right triangles, we have a couple of things in our toolbox. The first one we used already is the Pythagorean theorem. That's going to help us to find missing side lengths. We also have the rule of complementary angles because we know that all of the angles in a triangle add up to 180 degrees. And since it's a right triangle, the two non-right angles, or the acute angles, would have to add up to 90 degrees. So that helps us to figure out one angle if one is missing. And then finally, we could use our trigonometric ratios using SOHCAHTOA as we showed before. So one other thing that I want you to notice are the co-functions of sine and cosine. So for example here, if I was looking at sine of alpha my opposite would be A, and the hypotenuse is still C. And if I look at cosine of beta, cosine would actually be the same, because now for beta, the adjacent side is A, and the hypotenuse is still C. So something really interesting to notice is that sine of alpha will equal cosine of beta, and remember, alpha and beta are complementary. And similarly, we could assume that cosine of alpha will equal sine of beta. So it's a nice relationship. It's why sine and cosine are co-functions. Okay. So we're going to use everything in that toolbox we just talked about to solve this right triangle, where b equals 2, so that tells us the one opposite beta has a length of 2, and alpha is 40 degrees, so that's the angle opposite A. The way that I would start this out first is to use that complementary angle theorem, which tells us then that beta has to be the complement of 40 degrees, so we're left with 50. And anytime I solve for something, I'm going to go ahead and label that in my diagram because I might need to use it again later. Okay. Now I want to use, I'm going to use SOHCAHTOA in order to solve for one of the missing side lengths. So to do that, if you remember from geometry, let's say, for example, we're going to use alpha. I need to use the one that's labeled. So the 2 is labeled, and that happens to be my adjacent. And why don't we use A, which happens to be my opposite. So that means I'm going to need the one that includes opposite and adjacent, which is the ratio tangent. So tangent of 40 degrees will need to equal A over 2. Remember that order does matter in how we write this ratio. And if we want to solve for tangent now, we're going to have to multiply both sides by 2. So let's go ahead and multiply both sides by 2, and we get that A needs to equal 2 times tangent of 40 degrees. At this point, we can go ahead and substitute this into our calculator. Remember that you want to make sure your calculator is in degree mode. If you forgot how to do that, you're going to click on mode and then press highlight degree. And then we're going to type in 2 times tangent of 40. And we get 1.68. Notice I'm using 3 significant figures. IB always wants you to write at least 3 significant figures. But if I'm going to use this in another problem, I want to use all of the decimals that are in the calculator because we want to be as accurate as possible. But for now, I just want A, and I'm giving an approximation as approximately 1.68. So we're now going to solve for C, the hypotenuse. And we could use the Pythagorean theorem, but that again is going to use this approximate value for A, and it might not be as accurate as if we just went back to writing a new ratio. So let's write a new ratio instead. We'll still use the 2 because that's the one that's given, so that's an adjacent, and then C would be the hypotenuse. So since A and H are labeled, I'm thinking of SOHCAHTOA, and I'm going to use cosine this time. So cosine of 40 degrees equals the adjacent, which is 2, over the hypotenuse C. Doing some rearranging, this gives us C equals 2 divided by cosine of 40 degrees. And let's go ahead and type that into our calculator. Unfortunately, we can't do that in our heads. And we find that C equals about 2.61. Now, some really important checks are that the hypotenuse is the longest side length. And that is true because we've got 2.61 and about 1.68, so it does end up being the longest side length. That's important. I can also use the Pythagorean theorem to check to make sure that they equal each other. And it does satisfy the Pythagorean theorem. So we know that we've solved our triangle correctly. We've now solved for all missing angles and all missing sides. So we've completely solved the triangle. Go ahead and try to solve example number 3 now. And you can pause the video here. I put up the answer, so go ahead and check your work, and you can pause here if you need to. But again, we're using the same things that we used before to solve that right triangle. We're going to try an application now. So I have two boats that lie on a straight line with the base of a lighthouse. From the top of the lighthouse, 21 meters above the water level, it is observed that the angle of depression, so an angle of depression is between the horizon and the line of sight, so it's from that horizon line. To the nearest one is 53 degrees, but to the farthest is 21 degrees. So we want to figure out how far apart these boats are. And actually, in the picture, it's 27 degrees, so let's go ahead and fix it to 27 degrees. Now, I do want to label everything first. So we set the distance to the top of the lighthouse is 21 meters, so I'm going to label that. And if you can tell, we actually have two right triangles here. One is blue, and the other one I'll draw out in green. We're interested, though, in the distance between the boats. So I'm interested in this distance in red. And in order to find that, I'm probably going to have to find that leg that lies on the sea for both the blue and the green triangle. In order to do that, I'm going to need to know some of the angles in this right triangle. So I know these are right triangles. I noticed that the angle of depression is 53 degrees to the blue triangle, which means what's left over must be the complement of 53. So that gives me 37 degrees. And then we're going to go ahead and solve for A, which will be that blue distance. So I'm half labeled here opposite and adjacent from the angle of 37 degrees. So we'll use tangent. So tangent of 37 degrees equals opposite over the adjacent 21 meters. Rearranging this, I'm now ready to substitute this into my calculator. Again, making sure that I'm in degree mode. And A is approximately 15.8 meters. Now we want to find B, which is in the green triangle. And this is be the distance to the farther boat. So again, I'm going to use that same idea where I'm finding the complement of 27 degrees, the angle of depression. And that complement gives me 63 degrees. So I'll use tangent of 63 degrees will equal the opposite, again over the same 21 meters, because that's the height of the lighthouse. Again, we're going to rearrange. And we find that B has a length of approximately 41.2 degrees. Sorry, not degrees. This is a distance, so it's going to be 41.2 meters. I'm going to go back and we're looking again. We wanted the red distance, the difference between these distances from the lighthouse. So if I want that that distance, I'm going to subtract 15.8 from 41.2. It's approximately 25.4 meters apart. So you can always apply these right triangles in an application, and you just need to make sure you're carefully labeling the angles, because an easy mistake to make here is to use the 53 degrees and the 27. But actually those are our complements. So you want to make sure you're using the right angles when you're solving. Okay, lastly, we're going to talk about what happens if I'm not given any angle measures at all. How would I be able to solve that right triangle? So I have this right triangle here, and let's suppose A is 2, so this is alpha, and beta, or B is 3, so this is beta. Now we could easily figure out the third side using the Pythagorean theorem. So we would use 2 squared plus 3 squared equals c squared. So that gives us 4 plus 9, which is 13 equals c squared. So c is the square root of 13. And that will give us approximately 3.61. Again, you want to make sure you're rounding to at least 3 sig figs. So that helps us with the missing side length, but that doesn't help us with the angles. So to find angles, our trigonometric ratios are between side lengths, but we also have inverse trig functions. So if I was given the ratio, I could get the angle using inverse sine. So here I have two side lengths that I know, so I can use that to find the angle. So I want to find alpha. I notice that I have labeled opposite and the adjacent. So I'm going to use inverse tan. So I know that alpha will be the inverse tangent of opposite 2 over the adjacent 3. The order does matter here, and it's really important. On your calculator, you're going to have to press the second button to get inverse tan instead of just regular tan, because you're not giving it an angle, you're giving it a ratio. And the measure of the angle is approximately 33.7 degrees for alpha. Now to find beta, we can use those complementary angles again. So beta will need to equal 90 minus 32.7. And that gives us 56.3 degrees. Now we've solved for all the missing sides and angles, so we have solved the triangle. Your homework tonight is from the pre-calculus textbook, which is blue, and it's just the page 517 problems. Thanks for watching, and let me know if you have any questions.